So I tried it out and loop by key is way faster than use by key. And I think that's what we also discussed in the last lesson.
Yeah, I mean, actually, if you run it with very few data, what you will observe is probably a little bit random, because there's so much overhead of the Spark framework that yeah, the actual execution time is considerably small compared to that. So I tried it a couple of times, and it seems that yeah, it seems like a little bit random. So what is faster? But what should be observed is if you actually scale this up, like in this solution here, so I have a method which creates 500 megabytes of random data. Yeah, like this. So yeah, basically it's just backing up random data. And if I now run this, so let's see. So I set a number of tasks to force, so it runs a little faster. Alright, now if we look, here we can see, okay, I'm in section 2. So we have 14 seconds, and here it was like 10 seconds. Yeah. But it, as I said, it can depend on the number of data. The problem is that actually the advantage of the release by key section is that you have less shuffling. Like if you run it on a local machine, then shuffling is not such a big deal because it will take place on the same machine. So it will not necessarily slow down the processing. It's why the difference becomes much larger if you actually run it on a real cluster. Okay. But then let's see about test 2. So how do we write a Spark program which creates objects once per executor? Has someone implemented this? Maybe you can show us this solution. Come on. Did someone, but were you able to actually set up the ID and run the program? No? Okay. Oh, we can maybe discuss this tomorrow also. That's nice because yeah, I think it should. Maybe it's a little more complicated than I thought. But okay, but anyway, then I will show you my solution. Okay, so here, the basic idea is, so of course, using the symmetry pattern, I guess all of you know the symmetry pattern. It's basically just a design pattern that shows that you can create exactly one instance of the class. And we have a volatile field here for the executor symmetry. This field is returned in a synchronized block. That's to make it threads. Yeah, because so Spark programs run threads parallel. So if we are reusing the same instance, of course, we need to make sure that the code is thread safe. So I have a thread safe singleton implemented here, and
Now if we look into the main program here, I'm calling that partitions. And the partitions is using like an instance method of the single to get the single. So if you have multiple partitions running on the same executor, they will all get the same single instance. Yeah, that's why it's a single. So it's not, you won't have more than one single instance. And then you can actually call the process method of the singleton and pass the data item of the iterator to this method. And yeah, in this case, then the process method of the singleton will process the appropriate value. So this is actually only exists once. So yeah, like this, so we can run it. Yeah. So basically, yeah, why do we need this? Yeah, because it might happen that you have some kind of initialization going on, which should only happen once per executor and not once per partition. Yeah. Because, as I said, there are, of course, usually there are multiple partitions being processed. And, for example, you might want to have a database initialization for a database connection. So this should only be happening once. And therefore you can use basically a thread safe singleton. So that's the basic idea of it. Yeah, you need a volatile keyword to actually yeah, prevent the JVM from caching, so that's part of it. Then yeah, let's look at the task 3. So why are write transactions translated to multiple stages in the execution plan? Yeah, why isn't one stage sufficient? Why do we have very little? Yeah.
So like if on the first stage, like if we only have one stage, then everything will be executed sequentially. So if we split it out, then we can separate into stages where each stage we have a number of steps that we can do in parallel, but they depend on each other. And then the next stage we run on step that require that we go from the previous step, so on and so forth, and we can parallelize.
Yeah, so the reason is exactly that you have yeah, the next step requires the result of the step before that. So, and that's because yeah, the write transactions mean that we are dependent on results from other processes, right? So we're not only dependent on processing of a single partition, but also on the processing of other partitions as well. So we have to consider this. And therefore, we have a dependency, and this dependency is modeled by yeah, sequence of stages. So we have multiple stages in the execution plan if we have write transactions. It does apply to lower transactions, because lower transactions are not, yeah, basically just write transactions. It's a one-on-one relation. When does Spark create a job?
When an action is called?
Yeah, exactly. So every time an action is called, Spark creates a job. So if you're calling to actions, Spark will create two jobs. Each with its own execution plan. What's the most important difference between data sets, data frames, and RDBs?
Optimization means
Yeah, So actually the data sets and data frames line abstraction on top of Spark SQL, so they are being translated to RDBs via this optimization pipeline. So if you are working with data sets and data frames, Spark itself may try to optimize the query, and also it provides some more convenient abstractions. And the RDBs are actually what's already being translated into. Structured streaming has few element nodes, sort them by expected storage requirements of the results, and expanding storage one would be the storage, the element node is the biggest storage requirement. I mean, if you remember, there are complete mode, append mode, and update mode. So which one is the one with the biggest storage requirement? Yes?
Complete mode?
Yeah, exactly. So I mean, obviously, so it's very it's always right in the complete table, so it's of course fill your space pretty quickly. So then the next one is it more storage efficient to have append mode or update mode? Yeah, you're right. So actually, update mode will require the least space and less than append mode, because append mode always writes new really arriving lines, by update mode only if they change. So there's still a condition on this. So it's kind of a selection on the lines. Okay, why is distinct a right transformation? Yes?
So it needs to go through the entire dataset to check that if an element is duplicated or not. So.
Exactly. So if you want to find out if there are duplicates, of course you need to check the entire dataset. Otherwise you will only find like a local uniqueness. But you want, of course, to have global uniqueness. So to ensure that you are globally unique, you need to check every single item of the entire dataset. And of course, this means that we need to do shuffling, and that's why it's a right transformation. Is it possible that it may depend on the chosen partitioning whether Spark is able to successfully process all data or not? What do you think? Could it happen that if I choose another partitioning, then something will wrong, and otherwise it won't? Yes?
I think it will not affect the result, it's just performance-wise.
Yeah, I mean, you're right that I cannot really change the result once the computation completes. That's correct, of course. You're also right that it affects the performance. But the problem is that it may actually happen that if you have a very unbalanced partitioning, that the computation will actually not come to an end because you run out of resources. Yeah, because you may have a very big partition, then you may run out of memory, so it cannot be processed at all. So it can all actually make a difference that your cluster will actually succeed or not, because it will just give you some out of memory exception if you have very unbalanced partitioning. So that's why. For example, in the problem I showed you here, if I set the amount of data to be created to be much bigger than 500 megabytes, like 2 gigabytes or something, Spark will first tell me that it's one task has way too much data, so it should commence like 1 megabyte, but I have like 1 gigabyte, and then it crashes because I don't have enough memory to actually put it into a single task. So be careful that you always have even partitioning. And as I said, there is this repartition method. So check the partitioning and ensure that after doing some especially wide transformations of the data, ensure that you still have balanced partitioning, because otherwise some parts of your cluster won't have anything to do anymore, and others will have very big partitions. And then they might crash because they run out of memory. And even if they don't run out of memory, it may happen that it will take just a very long time to proceed until others are already done. So then it will not be running efficiently anymore. So that's why make sure that all partitions have roughly the same size. Even if they have roughly the same size, it can of course happen that some partitions may be more computationally expensive than others because it depends on the data what you want to process, right? So for example, consider you have like some kind of geographically distributed data, then if you would use like evenly distributed slices of the map, then some might contain more data because they are a more populated area and others don't have as much data. So it can happen that even you have chosen good partitioning, that some tasks take longer than others, because there's just simply more to do for some tasks than for others. Even though they get the same amount of data items, this is only about the amount of data items. And of course, it's a good idea to have even distribution, but it doesn't guarantee that everything takes equal time, right? So there's still some kind of volatility in the time and task takes to proceed. So be aware of that. So that's why you always have some kind of variance in the performance of the individual nodes. Some will proceed sooner than others. Okay. Good. I think maybe tomorrow we can help you a little also with getting the Spark running in the IDE, because I think it's important that you are able to really play around with it a little on programs just to get a feeling. I mean, it's always a different thing talking about something and using something. It's like you can talk a lot about playing the piano, but if you want to be able to play piano, you need to do it, right? So you cannot learn it by just observing it, And it's a bit the same with coding, I guess. So but maybe we can do this tomorrow. Then I guess that should be for today. Then let's meet tomorrow morning again. Have a nice day. Thanks for coming.